These bad boys right here. What's up, everyone? Welcome back to our second story edition in Lake Forest, California. The concrete is all in, and I guarantee you're gonna wanna stick around and see exactly what we're doing inside these walls to structurally support this new second story. Come on. Hey, if you haven't done it yet, be sure to like, subscribe, and hit that notification bell so you can be made aware of when we post awesome videos like this. Okay, so what you're looking at here is the inside of a stud wall. This is what's in pretty much all your residential walls. So inside the drywall, this is the inside of the house, you have these 2x4s. And this is what creates the structural support for the house. Here's a little known secret about 2x4s that most people might not know. They're not actually 2 inches by 4 inches. They're actually 1.5 inches by 3.5 inches. There's a couple reasons why people say they do that. One of the reasons could be that this drywall here is actually 1/2 inch. So if you add the 1/2 inch of drywall, now you have a truly 4-inch wall. Some people would say that it's because of the blades they use to cut these things. I'm actually curious, if someone knows more than me, please drop it in the comments. Tell me why a 2x4 is not actually 2 inches by 4 inches. Drives me crazy. So this wall, when it was built, was only meant to hold up a roof. A lot of times nowadays, whenever you have a multi-level home, they want you to not have 2x4 walls, they want you to have 2x6 walls. Well, it's not very functional for us to make this wall wider because everything's built around the 2x4. This sill plate here is 2x4, everything's built around this 2x4. So what they're asking us to do is they're asking us to sister, meaning join together another 2x4 on this side of the board. So you'll see double studs all the way across. Let me go find a piece of scrap wood. I'll show you what I'm talking about. Okay, this is a nasty board from concrete. We're not using this one. What we're gonna do is we're going to nail 2x4s together. So now you get the strength of 2 2x4s instead of 1 2x4. And that's gonna help us hold up the second floor. We're also gonna put an additional sill plate down as well to give more support down here. So these 2x4 walls are gonna get altered for the new weight. Let's go look at shear walls. This beautiful assembly here is a shear wall. Studs hold the vertical load of the house. That's what we looked at over there. The shear wall's job is to actually increase the lateral strength. We live in the great state of California. There's a little thing out here called earthquakes, okay? I myself, somewhat new to California, haven't been in a big one yet. But these plywood panels increase the lateral strength of the house so that if there's lateral movement, the structure remains steadfast. Now, the engineer tells us not only where in the house needs these shear panels, but they also specify the nailing patterns. There's like a nail every 1 to 2 inches all around the edge of these shear panels. And so they specify, the engineers tell us, at the edges, nail it every inch. In the middle of the field, nail it every 4 inches. So all this is specified by the engineers. These are shear wall panels. We're adding more of these to the house, especially on the areas that are getting a second floor added onto it. Let's move on to strong walls. This is a strong wall template. A strong wall, as opposed to a shear wall, isn't something you can just build on site. It's actually a specific engineered panel, sometimes made out of wood, sometimes made out of steel. And what they do is they put it at specific places on the structure to increase the structural strength of specific strategic points. When we put the concrete in, we put these with these bolts 3 feet into the ground. So this thing ain't going nowhere. Not only is it not moving, but the structural panel, which I'll show you, it's gonna give this corner right here a lot of strength. And that's gonna be important because what you'll see is this back patio area, there's a lot of big open spaces for wind to come through and people to walk through, and then there's like living space above. So you really want this corner to be nice and strong. Let's go take a look at those structural panels. These bad boys right here are the strong wall panels themselves. So if you look a little bit closer, you can see there's kind of like grains and lines running through all this. That's because what they do is it's similar to plywood. They take a bunch of little pieces of lumber and they glue it all together, which makes a stronger piece of wood than if you just cut it out of a tree. They also put steel at strategic points to increase the strength of the wall. So these strong wall panels are gonna go at specific places on this job site to increase the strength of the wall. So rather than needing a big long wall with all this plywood and all these nails, you can get a similar strength from just one of these panels. Now, they're not cheap, which is why we try to keep the use of them relatively low in the plans and in the construction, the planning and the engineering and all that. But they are awesome. We're really thankful we get to use them. If you haven't seen our video on the concrete pour, I'll put a thumbnail to it right here. You can click on it and take a look at that video. All this used to be excavations. There were footers, there was a slab, there was all this cool stuff going on here that, you know, looking at it now, you wouldn't think about what goes on under the surface, but it really is something to see that come together. Now that it's all done, it looks very normal. And that's what you want. You want everything to be structurally sound underneath the surface. And looking at it like this, you just would never know everything that's happened underneath. We got a lot of framing, a lot of structural work to be done. We're excited to do it, so be sure to follow along. If you have any questions, drop them in the comments, and I'll see you on the next one.